What we're going to be looking at today is how to create an electromagnet and then test its strength. In order to do this, what we are going to need is a solenoid. Now, a solenoid is just a coil of wire that we pass a current through, and when that electric current flows through the solenoid, it induces a magnetic field around it, much like a bar magnet. So our solenoid we're going to make from a piece of insulated copper wire. Here's the wire. It's covered with green plastic, and at the end you can see, it's difficult to see, but it has been stripped at that end. So you've got the green plastic and then just bare copper. This wire is about 3 meters long, so I can't really show it all on the video, but as we do the experiment, you'll see what's happening. So we've got our solenoid wire there. We've got 2 leads. They're going to connect that solenoid wire to this battery pack. We've got 2 crocodile clips to attach to the end of the leads so that we can connect it to that battery pack. Finally, we have an iron nail. Now, we call this a soft iron core for our solenoid. I'll be wrapping the solenoid wire around this nail, and this is made of iron. Iron, as you know, is a magnetic material. When you put a magnetic material into a magnetic field, it becomes an induced magnet, as long as it's in that magnetic field. Now, the reason we're choosing iron, I mean, we could use steel, is that iron is a soft magnetic material. That means the moment it's removed from the magnetic field, it loses its magnetic field. So by turning the current on and off, we can make the magnetic field of this iron nail turn on and off. If we'd used a piece of steel, which is a hard magnetic material, we wouldn't be able to turn it off. It would retain its magnetic field. It would become a permanent magnet. This is an induced magnet. So in order to do this, first thing I'm going to do is connect my crocodile clips to my leads. This is just to make sure we can make a good connection with our solenoid wire. So I'll connect both of those leads with crocodile clips. And the next step I'm going to do is to take one end of the lead, this one here without the croc clip, and plug it into 0 volts. Now that one is going to be connected to the start of our solenoid wire. There we go. Now I need to make this into a solenoid. Just a straight length of wire isn't a solenoid, so I need to make it into a coil. To do that, I'm going to wrap it around this iron nail. So the iron nail has 2 purposes. It's going to form the shape of the solenoid for a start, but also because it's this soft magnetic material, it will increase the strength of the magnet and turn off when we need it to turn off. So I'm going to wrap it 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to push them coils together. So there's 10 turns on this solenoid. As you can see in the results table, we've got 10 turns there. We're going to see how many paper clips it can pick up. Now this won't do anything at the moment. It's not connected to the wire, so it can't do anything. The wire's not been connected to the battery. So what I need to do now to turn it on is to pass a current through it. So at the other end of the solenoid wire, I'm going to clip this clip. That will be plugged into 3 volts. Now the reason I use 3 volts is if I go higher, 6 volts for instance, current has a heating effect on wires as it travels through them. The higher the potential difference, the bigger current will be passing through the wire, and if the current gets large, it can cause the wire to overheat and potentially melt the wire or burn me, and I don't want to get burned. So I'm just going to clip this on, and every time I want to do the experiment, I'll clip it. Every time I'm not doing the experiment, I'll detach it, because I don't want the wire to heat up through this experiment. So it's clipped on. What we should now have is a magnetic field around this iron nail. Let's just check. Will it be able to pick up any paper clips at all? No paper clips seem to be attracted to it. So for 10 turns on the solenoid, we've got 0 paper clips picked up. I'll just detach this for now to make it easier to wrap the next 10 turns. So in your results table, we're going to say there were no paper clips held with 10 turns. What I will now do is increase the number of turns on the solenoid by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You'll notice every time I wrap it, I'm wrapping it in one direction. I don't make the wire cross over itself at any point. I'll wrap it as close together as possible, but it must not cross over. This is because the wire has a magnetic field around it in a certain direction. If I make the wire move in the same direction, those magnetic fields will interact together and make an overall stronger field. If I start wrapping it backwards and forwards, they'll interfere with each other and it will weaken the magnetic field overall, and we won't get good results. So now that I've wrapped it 20 times, we're going to reconnect it to the battery pack. I'm going to see if it can pick up any paper clips now. So we've started off with 10 turns. It didn't pick up anything. We now have 20 turns. Will it pick up any paper clips this time? Well, this time it does have some paper clips attached. I'll just take them apart there. You can see 2 were picked up. So I'm just going to pop them paper clips back in there. I'll detach the wire so it doesn't overheat, and we'll write our next result. So after 20 turns, it managed to pick up 2 paper clips. You can guess what I'm going to do next. We repeat the experiment by increasing the number of turns. Another 10. 1, 2, 3. Oh, that one crossed over. Make sure the right way. 3, 4, 5, 6, 7, 8, 9, 10. Nice and tight. Put the coils together. We've got 30 coils there. 30 turns on our electromagnet. We're going to plug this into the battery pack and see how many we pick up. So again, dip it in there, see, does it pick any up? And you can probably see already, there's quite a few picked up. Some have dropped there, we won't count them. But looking at this, we've now got, well, that smaller one we're not going to use. We need to make sure it's a fair test. So we're going to use the same size paper clips. We'll try that again. How many does it pick up? I'll dip it in there. We'll just see how many have we managed to pick up. 1, 2, 3 paper clips this time. So, in our next section on the table, with 30 turns, we write down 3 paper clips held. We're going to repeat this. I'll remove the small paper clips because they can mess the results up. We need to make sure this is a fair test, and in order to do that, the paper clips all have to be the same size, same mass effectively. So now what we're going to do is up to 40 turns. Another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Push them all together. Our solenoid now 40 turns. I'm going to plug that back into 3 volts. And let's see how many paper clips we can pick up. Lifting up, I mean, I don't know if you can see that, but there are quite a few paper clips this time around. We'll detach that. I'll get rid of that one because, again, it's too small. Let's see how many we've got. Well, there's 2 there that are kind of tangled. 2, 3, 4, 5, 6, 7, 8, 9 paper clips. We have 9 paper clips with 40 turns. Let's repeat that with another 10 turns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got all the way up to 50 turns. You can probably predict what's going to happen. No surprises, but it's probably going to have more paper clips attracted. Again, lifting this up, we do have quite a stack of paper clips there now. It's getting to the point where we've run out of paper clips in the little dish, but let's count how many there are. 1, 2, 3, 4, oh, that one went back. 4, 5, 6, 7, 8, 9, 10. There's 2 there. It's hard to see, but there's 10, 11, 12, 13, 14, 15. 15 paper clips. So 50 turns, 15 paper clips. We'll do 60. We'll get the last couple of results really quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 60 turns. Plug it in and let's see what happens. Dip it in there. Try and pick up as many as we can. Oh, there's a nice large stack of paper clips there. Let's count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Again, let's repeat that one because it looks like either this or the previous is an anomaly. Let's dip it in there, try and pick them up again. Pick them up. Let's see how many there are. Quickly count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That seems a bit more reliable because we expect it to pick up more, the greater number of turns following the data's pattern. And finally, we're going to do 70 turns on our electromagnet. So let's finish this off with 70. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll push them all together. And we'll try this last one. See if we can pick up any more paper clips. Then 17. 17 seems quite high to be honest, but we'll see. Can it pick up any more? Well, this time it's only left 2 behind. It's got all those paper clips attached, you can see there. So let's just count how many we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 paper clips. So we can clearly see from our results that as we increase the turns on the solenoid, the electromagnet is able to hold more paper clips. If it can hold more paper clips, it must have a stronger magnetic field. So our conclusion is, as we increase the number of turns on a solenoid, the strength of the electromagnet increases because it is able to hold more paper clips. This is shown by our results because with 10 turns, no paper clips were held. With 17 turns, 21 paper clips were held.